Hello, everyone. Welcome to Geo 17.6 Outlook. My name is Sampath Ranasinghe, and I'm the product manager for the group. Let's get started with the first item on the list for this milestone, which is unified backups. Unified backups is the next generation backup solution for backing up GitLab installations. And it's a single solution that is intended to work across all of the different installation types. Today, we have a number of different ways of backing up each type of installation. We want to consolidate and provide a single consistent experience across all of the different installation types, such as Linux packaged, Docker, cloud native hybrid, and source code. We also envision it to power GitLab SaaS offerings, such as GitLab Dedicated and GitLab.com. GitLab.com support will come through the cells effort. Cells is the next generation architecture for GitLab.com, where we are building a much more horizontally scalable architecture, so we can continue to grow GitLab.com. And with that in mind, the first iteration is focused on supporting cloud backups. And what we mean by cloud backups is leaning on the vendors' tools to back up various parts of the GitLab data. So whether that be Postgres snapshots, disk snapshots, etc., etc. In this case, your cells will be deployed on Google GCP. So we'll focus on the first drop to be focused on 10K cloud native hybrid architecture on GCP. So we continue to iterate on this. We've made good progress, and we continue to push ahead. The key highlights we are hoping to achieve in this milestone is completing Cloud SQL backup and making good progress on the disk snapshots as well. Next up is Mover. Again, an effort focused around our cells initiative as well, which is our next generation architecture, as I mentioned earlier. As we move to this new architecture, which is the sharded architecture, we will need to move our customers from the current GitLab monolithic architecture to what we call secondary cells. Mover is the tool we're going to use for this purpose. So Mover will help, just like leveraging the geo technology of continuous replication. We will use Mover to migrate or copy over a customer's data to a secondary cell, while still allowing the customer to operate their GitLab tenant as usual. At some point, what we will do is pause the customer's tenant, or in this case, we are calling the tenant an organization. It is an encapsulation of the customer's entire data. We will pause that or put the organization into maintenance mode, preventing additional changes from happening, while we allow the existing changes to sync to the secondary cell. And then we will eventually cut over. When that is all caught up, we will package up the customer's Postgres data and move that to the secondary cell. And then we will re-enable the customer with read writes for their organization now on the secondary cell. The idea behind using Mover is to minimize the downtime in this migration to hours, or if not minutes, for a customer. And this way, we'll gradually move our customers onto secondary cells. So the initial drop, we will use package up the database and move the Postgres data manually to the secondary cell. The rest of the data, Git and object storage, will be completely managed by the geo mechanisms. Longer term, we will be expanding our capabilities to incorporate geo to work with logical replication. As some of you may already know, geo currently only works with streaming replication, and streaming replication has some limitations. The main one for our particular use case here being it replicates the whole entire database, where it's logical replication, we can replicate parts of the data. In this case, a specific organization's data. So we will be making Postgres replication, making Geo Postgres replication agnostic. So which means going forward, Geo will be able to use logical replication as well as streaming replication. And that's the effort Douglas, Nathaniel, and Scott will be doing in this milestone. They'll be working on making Postgres, Geo Postgres replication agnostic initially. Then we're in parallel, we'll also be rolling out Geo, the checksumming that Geo does onto gitlab.com. And you may, why do we want to do this? We want to get ahead of the potential data integrity challenges. Those of you who have deployed Geo will know quite well, the first time you stand up Geo, you will encounter some data integrity challenges where there are orphan database records or orphan files. Those need to be cleaned up. And we can do this ahead of time if we start to enable the checksumming on gitlab.com, which gives us a runway to clean up some of these discrepancies. So when an organization is ready to move, we have clean data for that organization. So we will not need to do troubleshooting in the middle of a migration. So this is a proactive step to get ahead of the data integrity issues by rolling out geo checksumming on gitlab.com. So again, we're going through the motions here by first deploying this to staging, monitoring the behavior, monitoring the impact on various services and resources, and then based on those results, we'll then be moving on to gitlab.com production itself for this. We'll be doing this in phases. We have feature flags that control each data type. So that's whether that be CI artifacts, Git repositories, or etc. We will be able to control each one, so we can manage the rollout of this slowly, rather than having this work across the entire data set in one go. And then lastly, we have some validation. We are moving quickly towards supporting Postgres 16. Postgres 16 has some great updates for us on various fronts, but also GitLab itself will be supporting Postgres 16, which means Geo and backups will also need to support that. And so the effort in this milestone is to validate that backups and Geo both work well on Postgres 16, but also they upgrade to Postgres 16 from the existing Postgres version. Currently supported is Postgres 14. That concludes our 17.6 milestone overview for the Geo group. I look forward to seeing you next time. Thank you for watching.